This episode is brought to you by my friends at Patreon. And, once again, by Singularity G3, whose images have given life to this journey since it began. Hi fellow seekers. This video is a continuation of a collaborative project I am working on with fellow space YouTuber Trolligi. Our first collaboration was a survey of the closest galaxies to our own, in which we hope to offer a traveler's view of our local universe. This sequel will focus on just two galaxies, the Magellanic Clouds, the most culturally important galaxies in our night sky after our own, with human histories spanning thousands of years.
Hey again, Trolligi here. It's lovely to be here again on this grand intergalactic journey, first traversing through the Milky Way and its closest, mostly diminutive dwarf satellites, and now arriving at this timeless pair of southern clouds, whose stories I cannot wait to tell. I also have my very own astronomy YouTube channel, which I would suggest to you if you enjoy this content. Alright, let's go.
Of all the wonders of our night sky, none have eluded Western scrutiny quite like the Magellanic Clouds. It is remarkable that they should have. They are the largest of the galaxies in orbit of our own, and, other than the Milky Way, extend across more of the sky than any other object visible to the naked eye. To even the most casual observer, they appear to dance across the night, like freshly fledged birds taking flight from the river of the Milky Way. Despite being one of our sky's defining features, the Milky Way's most visible satellite galaxies are too southerly to have inspired the great astronomical cultures of the Northern Hemisphere. Europe, the Middle East, India, China, even the Maya. For the vast majority of humanity, the Magellanic Clouds have formed no part of our collective mythic identity. We have told no stories of them, never pondered how they came to be. They are a region of the cosmos the peoples of the Southern Hemisphere can call their own. Across the vast seas of the South, many disparate cultures have attempted to divine meaning and instruction from their shimmering forms. Among the Sotho of southern Africa, the clouds form the tracks of the great horned star Canopus. The brightest star in the night sky after Sirius, Canopus forms an arc with the two Magellanic Clouds. Among the Garijari people of Western Australia, the clouds are twin ancestral spirits known as the Baganjimbiri, who were slain by the Quoll man Ngariman before being resurrected by their mother and sent up to the sky. Among the Wati people of Western Australia, the stars Canopus and Achernar are the fires of the Magellanic Clouds, who, as ancestral spirits, judge the souls of the dead. Among the Arimi of Tanzania, the clouds are a man and woman who aid the Pleiades in bringing rain. According to the Inca, the creator god Ataguchu kicked the Milky Way in a fit of anger, ripping out the small Magellanic Cloud and leaving the Coalsack, a dark nebula in the band of the Milky Way, behind. Among the Tupi-Guarani of Brazil, the clouds are fountains, or hugua, from which a tapir and a pig drink. To the Mapuche, in southern Chile, the clouds are menoco, water ponds that are in the process of drying out. The Coalsack Nebula, they warn, has already dried out. The small Magellanic Cloud is drying out, and as the large cloud finally evaporates, so the universe will end. So, with a legacy of mythic cosmogony from across the world, How did our two nearest naked-eye galaxies end up named after a guy who never mentioned them? Ferdinand Magellan is a hard man to like. He was a fickle, violent chancer whose heart lay in whoever could grant him the most spoils. Unlike contemporaries like Hernan Cortés, Francisco Pizarro, and Christopher Columbus, he didn't commit genocide, and his treatment of the natives of whose hospitality he did partake was, on occasion, gracious. But let's be clear. He died at the hands of Aboriginal Filipino tribesmen for a reason. His famous circumnavigation of the globe, conducted between 1519 and 1522, which, as you could probably guess from the previous sentence, he did not complete, was not for the sake of posterity, but rather to establish a purely Spanish route to the Spice Islands, which the Portuguese had just wrested from the Islamic world by force. Since all the major points on the eastern route to the Spice Islands were now in Portuguese hands, it behooved the Spanish to seek a western one. Magellan himself was Portuguese, and had even fought to wrest one of those ports, Malacca, to their side. But when his king told him to seek his favors elsewhere, he changed his name and donned the colors of his nation's rival, a decision which would foment suspicion in his crew, leading to him putting down 2 mutinies and drawing and quartering 2 of his captains. One of the ships ran aground. Another just turned around and went home. But nonetheless, Magellan did ultimately discover the navigable strait he had sought, which he called the Strait of All Saints, and today is called the Strait of Magellan. It is here that I must mention one of the most peculiar members of Magellan's expedition, Antonio Pigafetta. A Venetian, he decided, essentially on a whim, to sign up for Magellan's voyage, despite having no discernible experience or job description. His sole purpose on the expedition was to catalogue the events, geography, and natural history of the regions visited. And, as he was one of the 18 crew members who successfully completed the circumnavigation, we have his record today. In his work, he describes the locals of the Southern Americas as giants, with waists as high as a man's head. As said locals, the Tehuelche, are still around today, that statement can be objectively ruled as false. What we can assume true is his account of Magellan's treatment of the Tehuelche. After winning them over with the usual trinkets, he shackled 2 of them and loaded them onto his ship, just to prove he'd found them. Both of his passengers would soon die. His next native encounter, in what we now call the Mariana Islands, fared little better. After said natives made off with some of his cargo and one of his skiffs, he retaliated by burning their homes and killing several of their men. But when Magellan finally reached the Spice Islands, he appeared to have finally found his people. He was warmly received by the community, and even began a bromance with their king, who eagerly converted to Christianity. But all the greatest romances end in tragedy, and when he boasted to his new buddy that his crew could subdue and conquer one of his rivals, he sealed his own fate. All the cannon in the world were useless if out of range, and Magellan's ships were stranded beyond coral atolls that kept them far from shore. At a time when a good fire rate was 2 a minute, Magellan's muskets were overwhelmed by the flood of arrows and spears that confronted them. Forced to engage in melee combat, Magellan stuck to script by burning the natives' houses again. After a bamboo spear crippled his sword arm, Magellan was swarmed by native defenders, who carved him to pieces. Magellan actually failed to circumnavigate the globe twice over. In 1511, he took part in the siege of Malacca, in what is now Malaysia, and returned home to Lisbon via the Cape of Good Hope, together with a slave he'd acquired on the trip, known as Enrique the Black, or, less obnoxiously, Enrique of Malacca. If you allow for an 8-year stay in Iberia and a brief sojourn in Morocco, Magellan could be said to have circumnavigated the globe, if he had managed to reach Malacca again. Unfortunately, death cut him short, by a full 2,500 kilometers. This was a boon to Enrique of Malacca, who had accompanied Magellan on this voyage and whom Magellan had set free in his will. When the new captain, Juan Sebastian Elcano, refused to honor that bequest, Enrique simply waited for the ships to be docked at Malacca, then disappeared. No one knows what became of him after that, but it is possible, again allowing for his time in Spain, that Enrique of Malacca may be the first person to have circumnavigated the globe. While Magellan certainly deserves his strait, precisely why two galaxies share his name is less clear. Whatever claim he has to them is due not to him, but to Antonio Pigafetta, who wrote in his account of the voyage that, quote, "The Antarctic pole has no stars like the Arctic pole, but many stars can be seen gathered together, which are like two clouds, a little separated from each other, and a little dark in the middle. Between these are two stars, not very large nor very bright, which move little, and these two are the Antarctic pole." Despite my quoting him, Pigafetta's was not the first European description of the clouds. 20 years earlier, Amerigo Vespucci wrote in his Mundus Novus that, quote, "Among the others I saw 3 canopus. The 2 were very clear. The third was dark and unlike the others." Again, Vespucci mentions Canopus, the second brightest star in the night sky, which forms an arc with the large and small Magellanic Clouds. The dark Canopus, Vespucci mentions, is probably the Coalsack Nebula. And of course, beyond Europeans, there is the redoubtable Abdul al-Rahman al-Sufi, whose Book of Fixed Stars, published in 964, contained the first certain description of the Andromeda Galaxy. In it, he also wrote, quote, "Unnamed others have claimed that beneath Canopus there are 2 stars known as the feet of Canopus, and beneath those there are bright white stars that are unseen in Iraq nor Najd, and that the inhabitants of Tihama call al-Bakhar, the white ox." This is very likely the earliest description of the clouds from a northern hemisphere culture. In 1603, Johann Bayer published the first star atlas of the southern hemisphere, referring to the clouds as Nebula Major and Nebula Minor. In 1679, Edmund Halley, thanks to the telescope, produced the first comprehensive catalogue of the stars of the southern hemisphere. In it, he records that, quote, "The 2 nebulae, called by the sailors the Magellanic Clouds, are both of them like the whiteness of the Milky Way, lying within the Antarctic Circle. They are small, and in the moon shine scarce perceptible, yet in the dark the bigger is very noticeable." This would imply that the term Magellanic Clouds was employed strictly by sailors at the time, rather than astronomers. The 2 names would coexist for several centuries, with, for instance, John Herschel in his Book of Southern Observations referring to them by both. It was only in 1910, in that year's edition of the Norton Star Atlas, that the term Magellanic Clouds began to overshadow Nebula Major and Minor in astronomical textbooks. In September 2023, astronomer Mia de los Reyes argued that the Magellanic Cloud should be renamed. Given the wide number of indigenous cultures who have given them names already, and Magellan's spotty track record as a human being, a clamor is growing among astronomers for the cloud's proper place in humanity's mythic history to be recognized. And in February 2024, the IAU published a resolution that would have been voted on in August of that year. But it seems nothing has come of it so far. The broader history of galactic discovery is covered elsewhere in this series, but it was galactic pioneer Cleveland Abbe, better known today for his weather forecasts, who, in 1867, first identified the Magellanic Clouds as galaxies separate from our own, and in fact placed them in a wider system of galaxies throughout the universe.
The large and small Magellanic Clouds are 50 and 62 kiloparsecs from Earth, respectively, perpendicular to the galactic plane, and about 24 kiloparsecs apart. Models of their motions over time suggest that, over the last 800 million years, the Magellanics have come as close as 2.6 kiloparsecs and as far apart as 50. They are far more gas-rich than the Milky Way's other satellite galaxies, with a higher proportion of their mass composed of hydrogen and helium. This is due to their larger masses being able to retain more gas and thus spur on more star formation. The brightest and most vigorous star-forming region of our local group, the Tarantula Nebula, is in the Large Magellanic Cloud, and was the site of 1987A, the closest supernova to Earth in 400 years. Over the millennia, as they have come closer, both to each other and to our own galaxy, tidal force has kneaded that gas into new stars, creating epochs of star formation in the large cloud 5 billion, 2.5 billion, 1 billion, 300 million, and 50 million years ago. The 5 billion and 300 million year events coincide nicely with periods of star formation in the Milky Way, suggesting they were created in the same gravitational tug. At about 10 kiloparsecs across, and an eighth the mass of the Milky Way, the Large Magellanic Cloud is the largest dwarf galaxy in our local group, and its fourth largest galaxy, after Andromeda, the Milky Way, and Triangulum. The Small Magellanic Cloud is just 6 parsecs across, and is in fact outsized by the fifth largest member of the group, NGC 3109, though some doubt the latter is actually a member. Observations of the movement of hydrogen gas and young massive stars within the Small Magellanic Cloud led a 2024 paper to suggest that what we call the Small Magellanic Cloud may not even exist at all, as it may comprise two completely distinct galaxies, with approximately the same mass and separated by about 5 kiloparsecs from our line of sight. The farther galaxy has been dubbed the Mini Magellanic Cloud, and was probably birthed around 600 million years ago from a galactic karate chop from the Large Magellanic Cloud. The clouds are connected to each other by a river of star-scattered hydrogen, called the Magellanic Bridge, mostly comprising of gas siphoned off the small cloud, which tidal force kneads into new stars. Small numbers of stars in the large cloud orbit in opposition to the majority, suggesting that the large cloud drank them from the bridge. Surrounding the bridge is a shared cloud of hydrogen, suggesting that the two galaxies have been bound for some time. The Magellanics are in turn bound to the Milky Way by a far longer such river, called the Magellanic Stream. The majority of the Magellanic Stream is believed to have been pulled from the Small Magellanic Cloud about 2 billion years ago, though the Large Magellanic Cloud contributed sometime later. The east side of the Large Magellanic Cloud is closer to the Milky Way than the west, while the northeastern part of the small cloud is closer to us than the southwestern. As the clouds approach our galaxy, they will ram into its outer gaseous halo, pushing any remaining gas from the structures. The Large Magellanic Cloud is leading a gang of hooligans into the Milky Way's neighborhood. While the Small Magellanic Cloud is alone, the Large has up to 6 satellite galaxies of its own, and together they are creating noticeable disruptions in the orbits of those of the Milky Way satellite galaxies, visible in the southern hemisphere. Their speeds relative to the Milky Way are 378 and 302 kilometers per second, respectively. A sizable portion of the Milky Way's escape velocity, which is at 550 kilometers per second, and so the pair are unlikely to have orbited our galaxy many times, despite models suggesting that they are of comparable age to the Milky Way, between 12 and 13 billion years. The Large Magellanic Cloud is expected to collide with our galaxy within the next 2.4 billion years. The small cloud, astronomers believe, will be torn apart and likely become another stream slowly drunk by the Milky Way. Although they are often classed as irregular galaxies, both the Large and Small Magellanic Clouds possess central bars typical of older spiral galaxies, and the Large Cloud is even the prototype for its own class of galaxy, Magellanic Spirals, denoting spirals with only one arm. Some believe Magellanic spirals to be intermediate forms between spiral and irregular galaxies. The Small Magellanic Cloud may have once been a similar spiral galaxy, but it has since been warped and distorted by gravitational interactions with its larger siblings. Studies have shown that the stars in the Small Magellanic Cloud are moving in opposing directions, suggesting that it is being tidally disrupted by the large cloud, and perhaps supporting the mini Magellanic Clouds hypothesis. Surprisingly, despite being just over half as wide as its brother, the Small Magellanic Cloud has a stellar mass of 7 billion solar masses, compared to the large cloud's 10 billion. Both galaxies are vigorously forming stars, but the large cloud evidently more so, forming 1 solar mass worth of stars every 4 years, compared to 55 years for the small cloud. For reference, the Milky Way creates the equivalent stellar matter in about 7.5 months. The Tarantula Nebula is the crown jewel of the large cloud, a behemoth of a nebula in all respects, measuring almost 2,000 light-years across and housing some of the brightest, most massive stars known to humankind, such as the legendary star R136A1, the brightest object within the R136A cluster, which itself was once thought to be a superstar, measuring 3,000 solar masses in weight, and glaring with a light of over 30 million suns. Of course, we now know this object to be a part of R136, also known as NGC 2070, a supercluster of sorts, weighing in at a staggering 450,000 solar masses. It is thus clear that we're actually watching the birth of an entire globular cluster, a huge city-like conglomeration of stars that can sometimes span hundreds of light-years in diameter, rivaling entire galaxies. As the large cloud is larger and is forming more stars, it should be no surprise that it contains more so-called metals than the small cloud, at about half the fraction or metallicity of our home galaxy. Metals here means anything other than hydrogen and helium, and evidently astronomers are pretty terrible at naming things. However, that fraction was probably once much lower, as the large cloud had quite a slow start to the star formation race, and is really speeding up as it gets pulled around by the Milky Way, jostling its molecular gas clouds, which ram into each other and collapse, birthing hordes of new stars. The small cloud, owing to its lightness and relative small size, only has a metallicity about 1/5 that of the Milky Way. This has odd effects on its stars, such as red supergiants being several hundred degrees hotter than usual, and a conspicuous absence of the more evolved Wolf-Rayet stars. The large cloud has shown evidence for the presence of a supermassive black hole. If it exists, it would be surprisingly large, 1/17,000th the large cloud's total mass, or about 600,000 times the mass of the Sun. For comparison, our own galaxy's supermassive black hole is about 1/350,000th of its total mass. One theoretical model of the galaxy's collision argues that our galaxy's supermassive black hole is unusually small for its size, likely due to its having undergone relatively few mergers in its lifetime. When the large cloud finally does collide with the Milky Way, its supermassive black hole will merge with our own, bringing it up closer to average size. This hypothesis is bolstered by a 2011 study of Sloan Digital Sky Survey data that suggested that galaxies of the Milky Way's luminosity only rarely possess multiple satellites of the luminosity of the Magellanics, suggesting it may be only a temporary configuration. Given that the Magellanics are spiral galaxies, when the overwhelming majority of the Milky Way satellite galaxies are dwarf spheroidals, and the aforementioned richness of gas compared to other galaxies in the Milky Way's retinue, there has been much speculation that the Magellanic Clouds are not native planets of the Milky Way, but rogues from farther afield. But if so, from where? Simulations may have provided an answer. It seems that sometime in the distant past, between 6 and 9 billion years ago, two large spirals in our local group merged to form what we now call the Andromeda Galaxy. The fury of this event would have expelled matter equivalent to 1/3 the mass of the Milky Way, and much of the gas would have been expelled in the direction of the Milky Way. The Magellanics likely formed from one of the tidal tails generated by the event.
I hope this sojourn around our galactic neighbors has been a pleasant one. and once again I must thank Triligi for suggesting and continuing this collaboration. I hope you check out his channel, and as always, stay curious, fellow seekers.